Okay, quick disclaimer before I start this video. I'm obviously recording from home. The weather's really nice. I've got the doors open for a cross breeze, and somebody is outside, apparently like chopping down a tree or something, and my dog is not feeling it. And all the neighborhood kids are home being noisy, so there may be some background noise. I will try to talk loud enough to drown it out, okay? So for topic 5, we're going to look at solving linear equations that contain fractions, okay? So we need to remember a couple of things. In this section, we're talking about linear equations in one variable. That doesn't mean there's going to be a single variable in the equation. It just means there's going to be a single type of variable. So it's going to be like all x or all y or all z or something like that. Okay. And what makes these equations linear is the fact that the highest exponent you would see would be an exponent of 1. Okay. So that's what a linear equation is. And in this section, this topic, we're going to say, we're going to look at solving linear equations that contain fractions. Now, typically speaking, math students don't love fractions, okay? Fractions never did anything to you. You should not be afraid of fractions. However, when you are dealing with fractions, they just complicate things. It's just extra steps. So a lot of times, if we can eliminate fractions, let's go ahead and eliminate the fractions. It'll just make the equation easier to deal with. So that's what we're going to look at here, okay? So when it comes to any kind of assessment from me, I want you to clear your fractions simply because you're going to have a much greater chance at success if you do this. Okay. It's a really good skill to have. Okay. So I want you to practice clearing fractions. What that means is we're going to do a little trick to the equation that gets rid of all the fractions. And then we have just a regular equation with integers that we can then solve. So here are the steps. Okay. You're going to find the LCD. So just in case you forgot, LCD, let me go to black ink. LCD stands for least common denominator. And we did an example earlier where we were doing the addition property of equality. And we had to talk briefly about the LCD. Essentially, the LCD is the smallest number that your denominators will divide into, leaving a whole number result. So it's basically the smallest multiple of all of your denominators. So what can you divide by all of your denominators and get like a nice pretty result back? Okay, that's your LCD. Once you find your LCD, we then multiply all terms by the LCD. Now, some books will say multiply both sides of the equation by the LCD. I go ahead and tell everybody just to multiply all of your terms by the LCD, okay? Because essentially, if you multiply both sides of the equation, you're going to distribute anyway. So I just say, hey, let's just get to it. Let's multiply all terms by the LCD. And then once you do that, you'll have an equation that no longer contains fractions and is much easier to work with. And then from there, you can go back up and just use the steps we had for solving multi-step equations. So up here, steps for solving multi-step equations, apply the distributive property to eliminate parentheses, simplify on the left, simplify on the right. Our goal is to simplify the left and right so that we have at most 2 terms on each side, a variable term and a constant term. Once you have done that, you then apply the addition property of equality to get all of the variables on one side, generally the left, and all of the constants on the other side. And then at the very end, you apply the multiplication property of equality to undo the multiplication of the variable and its coefficient. Okay, so when you're clearing fractions, you just have this extra step before the regular 4 steps of doing the clearing of the fractions. Okay, so let's go ahead and practice this. All right, directions here say solve each equation. All right, simple enough. All right, so we have for part A, x over 10 plus 3 equals x over 4 plus 6. Okay, so it would be really helpful if we could just get rid of the fractions, because if we don't get rid of the fractions, we have to find equivalent forms of all of these terms, all 4 of them, where we have the LCD as the denominator, then we would add on the left, we would add on the right, and then we would still have to do some steps to solve, okay? If we can just clear the fractions, it makes it a lot quicker, a lot easier, okay? So let's look at our denominators. We need to find the LCD. So if you have denominators of 10 and 4, your goal is to find the smallest number that you can divide by 10 and divide by 4 and get like a nice pretty answer out of it. So here's kind of the process I go through. I look at the larger denominator first. Okay, so whatever your largest denominator is, in this case it would be 10, and I ask myself, will the other denominators divide into 10 evenly? Well, 4 will not divide into 10 evenly. If you took 10 and divided it by 4, you'd get a decimal, okay? So then I start looking at multiples of 10. So 10 times 1 is 10. What would 10 times 2 be? 10 times 2 is 20. So 20 is, of course, divisible by 2. 20 divided, or not 2, divided by 10. 20 divided by 10 is 2. But then could I divide 20 by 4 evenly? So 20 divided by 4 is 5. I get a nice pretty answer. That would tell me that the LCD here is 20. The good news is the LCDs we're going to work with are not going to be crazy in this class. They're going to be stuff that you can do pretty quickly in your head, okay? So now I know that my LCD is 20. What I want to do now is multiply both sides of the equation by 20 and then distribute. So for me, I just tell my students multiply all terms by the LCD. So I do this by hand, and I would say if you're a little unsure of yourself solving equations, do this by hand. Don't try to skip steps and do this in your head until you're like super, super confident with it. So I'm going to show you the process that I think you should probably start with. So we have 20, the LCD. We're going to multiply it by x over 10. We're going to multiply 20 by 3. Even though 3 isn't a fraction, we still multiply everything by the LCD. And then I get 20 times x over 4. And then 20 times 6. And then I just need to do some simplifying. Okay, so for the first term, I want to look at my denominator of 10 and I want to divide it into my LCD. So 10 will divide into 20 two times. And then what that does is it leaves me with 2 times x. So I would get 2x plus, well, 20 times 3, I just multiply. 20 times 3 is 60. On the right-hand side of the equation, I want to look at that denominator. 4 will divide into the LCD of 20 5 times. And what that does is it leaves me with 5 times x. So I get 5x plus, and then I want to take 20 and just multiply it by 6, and you should get 120. Okay, so I can't speak for the masses, but I would much rather work on solving this equation that I've just highlighted in yellow than the original equation. Again, if we kept the original equation, we'd have to find the LCD anyway. We would have to find equivalent expressions for all 4 terms. We would have to add the expressions on the left, add the expressions on the right, and then still take time to solve the equation, okay? And if you may end up having to do some work with it. It gets complicated. Let me just say that. It gets really complicated if you try to keep the fractions in the equation, okay? So we cleared the fractions, and now we have something that's relatively easy to solve. So what I want to do, I don't need to simplify the left or the right. I've got a single variable term and a single constant term on the left and the right. So what I want to do now is apply the addition property of equality to get all the variables on the left. So I'm going to start with the 5x. I want to move it to the left. So since 5x is positive, what we want to do is we want to think of that as plus 5x. Okay, I'm trying to get all the variables in a single term, so I need to move the variables from the right to the left. So if I have plus 5x, the way I would undo that from the right would be the opposite of addition. I would subtract. So on the left, when I simplify, I get 2x minus 5x. That's just going to be negative 3x. 2 minus 5 is negative 3. So I get negative 3x plus 60 equals. And then on the right, 5x minus 5x, that's just 0. And then 0 plus 120 is 120. It would be totally normal to say that the 5x's cancel, but please understand why the 5x's cancel. They cancel because their sum is 0, okay? Now, we've got all the variables in a single term on one side. What we need to do is isolate that variable term. So now my issue is plus 60. How would I undo or move plus 60? Well, I would subtract it. So I want to subtract 60 from both sides of the equation. On the left, 60 minus 60 is 0, so we would kind of get lazy and just say, hey, the 60s cancel. And then negative 3x plus that 0 is just negative 3x. And then on the right, 120 minus 60 is positive 60. So we got rid of the fractions. We didn't have to do any simplifying after that. We didn't have to like combine like terms is what I mean. And then we applied the addition property of equality. We had to do it twice, once to get the variables together, once to get the constants together. And then we're finally at a point where we have a single variable term equaling a single constant term. This is when you apply the multiplication property of equality. We need to undo the multiplication of negative 3 and x. The way we undo multiplication in math is we divide. So we want to divide both sides of the equation by negative 3. On the left, negative 3 divided by itself is just 1. 1 times x is x. So yes, we would very lazily say, oh, the negative 3's cancel. They do. Just understand why. They cancel because their quotient is 1. Okay? And then finally, 60 divided by negative 3 would be negative 20. And if we write this fancy, we would say the solution is the set containing negative 20. Okay, so I am fine if you write your answer like this. Just know that this is kind of like the fancy formal way to write your final answer. Okay, so that is example A. Let's look at, or not example A, it is example 5, part A. Let's look at part B. Let me scoot this. I have something on my screen I need to scoot. Okay, so looking at part B, we have 3x plus 2 divided by 4 minus x over 12 equals x over 3 minus 1. So looking at all of those denominators, let's first determine the LCD, okay? So I always start with the biggest denominator, and I ask myself if the other denominators will divide into it evenly. So let's start with 12. Will 4 divide into 12 evenly? Yes. Will 3 divide into 12 evenly? Yes. So that tells me that the LCD is just 12. 12 will divide into itself evenly. 3 and 4 divide into it evenly. We have an LCD. And once you find your LCD, you want to multiply all terms by the LCD. If it is easier for you to think of it as multiplying both sides of the equation by the LCD and then distributing, that is also fine. Okay? So I've got an LCD of 12. I'm going to multiply it by each term. All right, so I've multiplied all 4 terms by the LCD. Now we want to simplify and just clear out those fractions. So in the first term, I have a denominator of 4. I want to see how many times 4 will go into the LCD of 12. So 4 will go into 12 3 times. And what this does is it leaves me with 3 times that entire numerator. Keep your numerator in parentheses. For the second term, I want to see how many times my denominator of 12 will divide into my LCD of 12. So 12 will divide into 12 one time. So I'm left with just negative 1 times x, or just minus x. For the third term, I want to know how many times 3 will divide into 12. So 3 will go into 12 4 times, and I'm left with 4 times my numerator of x, so 4x. And then finally, I have minus 12 times 1. Well, 12 times 1 is just 12, so minus 12. Okay? And at this point in time, we have just a nice, pretty linear equation with integer values. It's much easier to solve than when you have those fraction values, okay? So we want to just do the regular old steps, the 4 steps to solve a multi-step equation. First step is get rid of your parentheses. So we do need to distribute on the left. We're distributing a positive 3. So 3 times 3x is 9x. 3 times 2 is 6. And then just rewrite the rest of the equation. Don't try to do bunches of steps in your head. This is a situation where show all of your work step by step, nice and organized. Kind of mimic the way I solve these until you get really, really comfortable. And then, when you're super comfortable, you might be able to take a few shortcuts. But for now, really show all the steps that I'm showing. Okay, now on the left-hand side, we do have like terms that we can combine. We have 2 terms that contain x's. We want 1 term that has an x in it. So we want 1 variable term. So I want to take my 9x and subtract 1x. So 9 minus 1 is 8. So the left simplifies to 8x plus 6. And then the right, it's good to go. It's 4x minus 12. At this point, when you have at most 2 terms on each side, a single variable term and a single constant term on each side, this is when you apply the addition property of equality. We want to get the x's together, typically on the left. All right, so that 4x on the right, I want to move it to the left. So how would we kind of like undo that positive 4x? Well, think of positive 4x as plus 4x. How would we undo addition? Well, we would subtract. So we're going to subtract 4x from each side. Remember, we're maintaining balance. So whatever we do to one side, we have to do the same thing on the other. And then on the left, 8x minus 4x is just 4x. So positive 4x. Rewrite the rest of the equation. And then on the right side, that 4x minus 4x just becomes 0. So we would say these cancel to become 0. 0 minus 12 negative 12. Okay? So now we've got our x's in a single term. We want to isolate that term, so we need to undo this plus 6. So the way we undo addition is subtraction. So I'm going to subtract 6 from both sides. On the left, 6 minus 6 is 0, so we would say the 6 is canceled to become 0. 4x plus 0 is 4x. And then on the right, negative 12 minus 6 is negative 18. Okay, so at this point, we have a single variable term equaling a single constant term. This is when you apply the multiplication property of equality. We want to undo that multiplication of 4 and x. So the way we undo multiplication is we divide. So we are going to divide both sides by 4. On the left, 4 divided by 4 is 1. 1 times x is x. And then on the right, remember, I mentioned this in a previous video. It's sometimes hard for students, but when you're just solving these generic equations, we want our final answers to be simplified fractions. We're not looking for decimals. We're not looking for mixed numbers. Decimals and mixed numbers sometimes are really important in like a word problem, but for just these generic equations, simplified fractions is the way to go, always, okay? So negative 8, well, I don't want to say always, almost always, simplified reduced fractions. So we have negative 18 divided by 4. This will definitely reduce. Both of those numbers are even, so we're going to divide them by 2. Negative 18 divided by 2 is negative 9. 4 divided by 2 is 2, so this would be my final answer. And if we wanted to make it fancy, we would write it as a set. So we'd write it in set notation. So we would say the set or the solution set contains the value negative 9 over 2 or negative 9 halves. Okay, so just a quick recap. To clear fractions, you find the LCD, you multiply all of the terms by the LCD, and then you just follow the regular old steps for solving an equation. And I feel like this should actually say from topic 4, not topic 2. So here are the regular 4 steps for solving an equation. Get rid of parentheses, combine like terms on the left and right, apply the addition property of equality, and then end with the multiplication property of equality. All right, so with fractions, I insist that you clear your fractions, okay? In the next video, we're going to look at clearing decimals. It's not nearly as magical, it's not nearly as helpful, but there is a trick to make it a little bit easier. Clearing decimals, not as interested in. Clearing fractions, you absolutely need to know this, okay? So I'll see you in the next video where we clear decimals.